You know that feeling? You're in an escape room, the clock is ticking, and you finally place that weird-looking artifact onto a pedestal, and a hidden door just clicks open. It honestly feels like straight-up magic. But what if I told you that behind that magic is some really clever and actually surprisingly simple technology?
Right? That's the big question we're going to dig into. How does this room, just a room, know what you're doing? How does it react to your every move, trigger all these cool events, and lead you to the next clue, all without some person hiding behind a wall pulling levers?
Well, we are going to pull back that curtain. We'll start with the puzzlemaker's basic toolbox. Then we'll look at a couple of classic puzzles, like cracking a color code and dodging lasers. After that, we'll uncover the digital brain that makes all the decisions, see how these ideas actually become real, and finally, we'll talk about the powerful skill you're learning just by understanding all this.
Okay, let's get into it. You might think that to build one of these awesome interactive puzzles, you need a huge lab full of super complex electronics, but you really don't. It all boils down to just a few key ingredients.
Think of it like this, right? You've got sensors, which are basically the puzzle's eyes and ears. They detect what you're doing. Then you've got motors, which are the muscle. They can move a lock or pop open a secret door. And finally, you have lights and sound, which are kind of like the puzzle's voice. They give you clues, tell you you're right, or, sound a big scary alarm. Pretty much every piece of interactive magic is just a clever mix of these four things.
All right, so let's see these tools in action. Picture this. You walk into a room. It looks like an ancient tomb, and right in the middle, there's a pedestal.
So the puzzle seems clear. You gotta find the right object, out of maybe a bunch of them, and put it on that pedestal. Let's say you find 3 gems scattered around the room, a red one, a blue one, and a green one. Only one of them is the key. So how in the world does a simple pedestal know which one you picked?
Well, the secret is a tiny little color sensor, probably hidden right inside the pedestal. It's basically an electronic eye that does one job, and one job only. It looks at an object and tells you its color. That's it. It's not smart, it's not thinking, it just reports what it sees. And this shows you exactly how the logic works. The puzzle designer just writes a super simple rule. The code basically says if the color sensor sees the color red, or, as a backup, if a distance sensor sees that anything is super close, then you trigger the unlock command. It's just a basic if-then statement. So you place the red gem, the if condition becomes true, and boom, a motor unlocks the next clue. It's simple, but so effective.
Okay, let's jump to another classic puzzle, one that builds on this idea. You've seen this in like a dozen spy movies for sure.
You open a door and bam, a hallway crisscrossed with glowing red beams of light. Your mission, should you choose to accept it, is to get to the other side without touching a single one. Break a beam and the alarms go off, but are those real lasers? Nah, almost never. The secret is something much safer, and it actually works with invisible signals. I want you to meet the distance sensor. This little guy works just like a bat. It sends out a little pulse of sound that's super high frequency, it's ultrasonic, so you can't hear it, and then it just waits and measures how long it takes for the echo to bounce back. By timing that echo, it knows exactly how far away the nearest object is.
So each laser you see is really just a distance sensor aimed across the hall. It's just sitting there, constantly measuring the distance to the wall on the other side. The second your hand or your leg gets in the way, the distance it measures suddenly gets a lot shorter, and that change is the trigger. The rule is simple. If the distance I'm measuring is less than, say, 10 feet, then sound the alarm. You've just made a high-tech security system with sound waves. How cool is that?
Okay, so we have sensors that can see color and others that can measure distance, but what's the central brain that connects all this information and decides, okay, now's the time to unlock the final door? Well, it all comes down to a concept that powers pretty much every digital device you own.
It's called Boolean logic, and trust me, it is shockingly simple. In the world of Boolean logic, everything is either true or false. That's it. There's no kinda or maybe. A light is either on or off. A door is locked or unlocked. You've either solved the puzzle or you haven't. True or false. That's the whole game.
And what's really cool about this slide is how it breaks down the 2 most important rules in any puzzle designer's playbook. And or. And logic means that multiple things have to be true at the exact same time. You have to press button A and button B to make it work. Or logic, on the other hand, is a little more forgiving. Only one of the conditions needs to be true. You can use the red key or the blue key. Either one works. And this is where it gets really fun, because puzzle designers are basically logic architects. They just stack these simple and or rules to create mind-blowing complexity. So to open the final door, you might have to solve the laser grid and the color puzzle, which itself might require you to have found the red gem or a secret hidden switch. It's all just layers of simple true or false questions.
So we've got the components, we've got the logic, but how do you actually build one of these things? I mean, these amazing puzzles don't just appear out of nowhere. They're built through a really careful step-by-step process.
First, obviously, you brainstorm ideas. Then you build a rough prototype, a model. Next, and this is the most critical part, you program the logic and you test it, like over and over and over again. Then you get feedback. You have someone else try it. Does it actually work like you thought it would? Is it fun? Is it confusing? And finally, you just refine and iterate, making small tweaks based on all that testing and feedback until it's just right.
And this quote from a LEGO education guide, man, this really gets to the heart of it. When something goes wrong, and trust me, it always goes wrong, you don't just throw everything out and start over. You make one small, deliberate change, and then you test again. Is the sensor maybe at the wrong angle? Did I use an and when I should have used an or? It's this methodical process of testing and fixing that gives us those really cool, reliable puzzles.
Okay, let's zoom out a bit, because understanding how to build an escape room puzzle is about way more than just fun and games. You're actually learning a fundamental skill for, well, pretty much everything in the 21st century.
That magic we keep talking about, it's really just a powerful skill called computational thinking, but in disguise. It's this ability to look at a really complex problem, break it down into smaller, bite-sized pieces, find the patterns, and then develop a step-by-step solution that a computer or, a puzzle can actually follow.
And this skill is literally everywhere. The same kind of logic that makes a puzzle react to a red gem is used in automated factories. That distance sensor in the laser grid, it uses the same basic principles as the backup sensor in a self-driving car. The whole process of building, testing, and iterating, that is exactly how engineers develop security systems, smart home devices, and solve all kinds of huge real-world problems. So, the next time you're in an escape room and some hidden door swings open, you'll know. It's not magic, it's a sensor, a motor, and a few simple lines of logic. So the real question is, now that you know the secrets, what kind of magic would you create?